I didn't record my last lesson, so the poor children don't know how to do this. All right. There are 4 properties of logs. There's product, and you're going to create like a chart that kind of has like 3 sections, 3 columns to it. Quotient, power, and equality. And I'll move this down in a minute. Something like that in your notes. And in this column, I'm just going to give you what the actual property is. And then in this last column, I'm going to show you an example. So we're just doing properties today. This is going to lead us into what will help us solve for logs, even more logs. So we want to solve for them. So let's start with product. The product property says the following. If you have a log base b of mn, meaning you're multiplying 2 things next to it, that you can actually rewrite that as log base b of m plus, this is of course going to get too squishy, log base b of n. Why is it a plus? Because remember, logs are just exponents. And what do you do when you multiply exponents? What do you actually do with the exponents? You add them. So that's where that came from. Plus, I know, I'm sorry, log base b of n. So you're right, log b m plus log b n. I know it's a b. Oh my gosh, stop. It's the pen. Stop it. So let me show you this one. Log base 2 of 9x. So how would you write this out? It's called expanding it. How would you expand it? You would write log base 2 of 9 plus, what would come next?
Log base 2 of 6.
Correct. That's it. Okay? So that is the property that says if you're multiplying, you can actually just write it as at addition. That's the first property. All right, then there's the quotient property. Log base b of m over n. So what do you think is going to happen here?
Subtract.
Exactly. When you divide exponents, you actually will subtract those that have the like bases. So you would say log base b of m minus log base b of n. I should have given a wider section here. So let me give you an example again. Log base 5 of 4 over w. And you would rewrite this in an expanded notation. You'd say, okay, log base 5 of 4, which is the top number, minus log base 5 of w, which is the bottom number. It always has to go from left to right, top, bottom. Okay? Now, the power rule is even easier. Log base b of m to the p. If you have something that you're raising to a power, you actually take that power and you move it to the front. You're allowed to do that. It's a power property. So it actually equals p times log base b of m. And again, let me give you an example. Log base 3 of x squared. Okay, you are allowed to take that 2 and move it to the front and rewrite it as 2 log base 3 of x. That is going to definitely help us when we get to solving for logs and x's inside of logs. All right, and then one more property before we actually practice some examples of this is the equality property. And the equality property says that if you have a log base b of m and it equals a log base b of n, could you finish the rest of that statement for me?
M equals n.
Correct. If you have 2 logs with the same base on both sides, then whatever you're taking the log of, they must be equal. So just to show you, if I have log base 8 of 2x, and I say log base 8 of 5x minus 3, I am allowed to mathematically almost like ignore those log base 8s. By the way, they both have to be the same log to the same base. If this was a log base 2, you'd have to do a totally different thing, or you couldn't do it. And then you just set these two equal to each other. So 2x equals 5x minus 3. X is 1. Okay, now, this sheet that I'm giving you, we're actually going to do most of it in class, depending on how fast you are. You can get this done with me. If you can't, you're going to have to do it from work. But right now, I want you to do, at the top, 26 to 31, which is using these properties. 26 to 31.
Yep.
How do you feel without Brian next to you?
Switch Brian up here pretty good. We can move on. He's been already like brothers.
Thought for sure he would say lost, but he didn't.
He gets a mind degree.
Okay, so 26 through 31 say expand the expression. The word log will be used repeatedly. So you should say log base 6 plus log base 6, whatever, okay? So try to work through all these right now, and then I'll go over a few in a minute.
Okay.
What? You are not, there's no solving. You can't solve. See how you did on one of them. How did you write like number 28? What would you say? Log base 10 of xy squared. Anybody want to go for it? Brian?
Log 10x plus 2 log 10y.
Nicely done. Yeah, that you are adding the x and the y squared, and then the 2 needs to come in front. So that would be it. If you got that one, nicely done. That's pretty much what you're going to be doing number 30. Let's do 29 real quick, though. When you divide within a log, you're actually doing what operation again? Subtract. So some of you, and I know you like the steps, so I'm just going to show you the steps. You probably wrote it like this at first. Yes, you are minusing the x, y, and the 3. But this right here is multiplying within the log, so you can actually even break that out more, which would be log base 4 of x plus log base 4 of y, then minus log base 4 of 3. Do you put this in parentheses? You could. You usually read your logs from left to right, so you do the operations on the left to the right. So make sure you know how to do that. All right, let's move on to the condensing one. So if you didn't finish up here, you're going to have to finish it. You'll have time. Let's do this right here, this condensing. I'm going to do the evens. You can do the odds right now. We're going to do these together. Condense, the word log will be used once. So if I have log base 3 of 7 minus log base 3 of x, what would that one be? That's very easy. How would you condense that? Correct. Okay. By the way, don't put the log 3 at the top and don't put it at the bottom. Just put it out to the side. All right, this one, log base 4 of 5 plus log base 4 of x plus log base 4 of y would be log base 4 of, what am I just going to?
5xy.
Correct. 5xy. Easy stuff. Okay. Anytime there is a number in front of the x, you're going to want to do that first. So bring this 2 to the power of x, bring this 3 out to the power of y. So really this is log base 2 of x squared minus log base 2 of y cubed. And now you should be able to rewrite this. What would that be? Log base 2 of
X squared over y cubed.
Good job. Okay. All right, now this one is actually a typo error. If this was a log base s, you would not be allowed to condense it. You just have to leave it alone. So just pretend that's a 2 though. Sorry, that was a typo error. So this 2 would go to the y, and you would have log base 2 of x minus log base 2 of y squared. And then obviously you'd finish it off as log base 2 of x over y squared. See if you can do this side now, 33 through 39. Log base A of?
Log base A of 3. Log A 3.
7/8.
Log base A of 3. I know. All right, let's find out why. You're close. I know where you're going with that, so I'll get you. The 3 becomes the power of 2. So 2 to the third is actually what?
8.
So it's log base A of 8 plus log base A of 6. And again, working left to right, if I'm adding, what do I actually do with the 8 and the 6? I don't add them, I multiply. So it's log base A of 48. Okay. Then you subtract, bring the 2 to the top of the 4. So it's log base A of 16. And again, when you subtract, you don't actually subtract these numbers, you divide these numbers. So it's log base A of 3. So good try. That's a common error. Close enough. All right, one more thing, and then I've got a few examples to show you. And then if you, again, you did this, you did half the homework. Do you notice how it says log equal to a log? Log equal to a log. This one says log plus log equals log. When you're solving with logs, you are only allowed to do 2 things. You're either allowed to have 1 log on one side and you do the whole zoop thing, or you're allowed to have 1 log equal to 1 log. When you have multiple logs on one side, you must condense first. So I'm going to do this one with you first. So let's condense this side to be 1 log. What would it say? Log base 10 of what?
3x.
Yeah, some people are like, do I write x3? No, you know how to write 3x. It's the same thing, okay? Equals log base 10 of 12. And this is the equality property. If you have a log base 10 of 3x on this side, log base 10 of 12, you can simply ignore them and just set 3x equal to 12. So what would x equal? 4. Okay? Any of them causing you problems? Like, you know how to do 44? 45? Anybody else? Good? What's 44, by the way?
3.
Okay, good. What's 45?
3.
Okay, good. I think you'd be fine. All right, put that away. What's 42? Oh, yeah, that's right. Log base 3 of 5 over x equals log base 3 of 2. So you'd write 5 over x equals 2 over 1. And I would crisscross multiply. And I get 2x equals 5. So x is 5/2. Okay, good one. All right. Few more examples and we're done. They don't have this as a property, but it's something that really you should know for the first question in the bookwork tonight. Do you know what log base 2 of 2 is? Or log base 5 of 5 is? Or log base b of...
1.
Why 1?
Backwards.
Backwards C. 2 to the what makes 2? 1. 5 to the what makes 5? B to the what makes B? So it's 1. So here's what you're going to do for the first part of your homework tonight. Write this down. Log base 4 of the 5th root of 64. Log base 4 of the 5th root of 64. When they are giving you a base, what they're really telling you is, hey, try to get that number to be that base. Try to get 64 to be base 4. Does anybody know what 64 is as a base 4? Because you should. It's 3. 4 squared is 16. 4 cubed is 64. So if I were to rewrite this, I'd say log base 4 of the 5th root of 4 cubed, right? 64 is 4 cubed. Or even a better way to write this would be log base 4 of 4 to the what power? How do you write a radical? We did that way in the beginning of the year. How do you rewrite 5 to the fractional power?
5/3.
Not 5/3, other way around. 3/5. This becomes your denominator. So now that you have log base 4 of 4, you see that log base 4 of 4? That cancels to really 1. So your answer would just be 3/5. Log base 4 of that is 3/5.
Wait, what was the last step after you got?
Log base 4 of 4, right? Because log base b of b equals 1, honey. They cancel themselves out. If you take a log of 4, log base 4 of 4, they cancel each other out. They're like inverse operations to each other. So your answer would be this. If you want, I could set it equal to x, and I could do the whole. So 4 to the x equals 4 to the 3/5. What does x equal? 3/5. All right, so let's do it here. What's 36 as a base 6? 6 what? 6 squared. But because it's under a cube root, how do I write that? 2 over 3. And again, because you have log base 6 of a 6, that is their inverse operator. They're going to cancel, and your answer is just going to be 2/3. Okay? So know that for homework tonight, because you'll have like 2 questions on there that you'll have to do about that. And then finishing off here, our last 2 examples, I guess 3 and 4. And I'll just write the last one here. Okay, in the future, in this test, you're going to get a test with all logs on it, and you have to solve and know how to do it. And I will actually teach you E's and LNs and all that. And so you have to kind of please listen to what I'm saying. If you have one log on one side, you with me? You do the backwards C. Okay? One log, one side, do this. But if you have multiple logs, you condense and then you set them equal. Multiple logs, condense, and set equal. Okay? So you've got to know the difference, because again, I'm just gonna give you a problem like this and then I'll give you a problem like this on the next test, and you got to just like, what do I do? Do I do the whole backwards thing or do I not? Just know one log, one side, do the thing. So I'm gonna go like this. I'm gonna go x to the 1/2. What's it equal? Does it equal 1/3 or does it equal 64 to the 1/3?
1/3.
64 to the 1/3. It equals this whole thing right here, okay? So now it's up to you, however you want to solve this. There was multiple ways in the other class, okay? That 64 to the 1/3 is actually, well, let's leave it like this. How do you want to solve it? I'll ask you. We're solving for x. How do I undo a 1/2? Square it. So this would cancel and you're left with x equals, anytime you have a power to a power, you multiply. So this would be 64 to the 2/3. 1/3 times 2 is 2/3. And so now what am I asking you to do? Well, I'm asking you to take the cube root of 64 and then square it. What's the cube root of 64? You should know that one. We just did it. 4, and then 4 squared is 16. That's the answer. So the big idea here is one log, do the loop. Do the loop. Okay? But multiple logs, condense and set equal. And I need to show you this one, even though you just did examples here. We got to get this one in. It's totally different, and I need you to be aware of something. Okay, so let's condense this side. Log 11 of x plus log 11 of x plus 1. What would that become? Log 11 of what? Condense it. What would you do with these two? You don't add them, you do what? Multiply them. So x times x plus 1, which would really be log 11 of x squared plus x, equals log 11 of 6 on the other side. Okay. Oh, now that I've got log 11 on this side and log 11 on this side, what do I do with these two then? Just set them equal. X squared plus x equals 6. So subtract 6 over. What two numbers do I have? Two numbers multiplied -6, but add to 1. 3 and 2. And what? What would be my answers? X equals
-3
and 2. Are those the answers? No.
Oh.
You know this. You knew something was tricky. She can't be that nice. She always throws those extraneous roots at us. Here they are. In logs, this number right here, what you're taking a log of, not the base, that what you're taking a log of is not allowed to be negative. It can't be. It can never be negative. Not allowed negative. That cannot be negative. Why? Well, let me show you. Let's just put -3 there. Let me set it equal to x and do our whole loop-de-loop thing. 11 to the x would ever give me a -3. Is there any number is there any power of 11 that would give me a negative number? Is there any power of anything? No, you're always going to get a positive. So that cannot be negative. So this is another example of an extraneous root, my friends. 2 is the only answer. If 2, though, didn't work right here, like if it was like x -7 and you plug 2 in, then 2 would also be extraneous, okay? If this was, however, x squared, listen to me. I'm giving you a huge hint for the test, and I know you're not going to remember this. If this was x squared, could you put in -3?
Yes.
Yes. So look for that. All right? So that's it. Homework tonight. You can start on it now. I know I'm losing you. I'm losing you. I can almost like feel the life sucking from you right now. Here's your homework.